A square loop of wire with sides of 2 centimeters is placed in a 0.3 Tesla magnetic field that is directed toward the right side of the page. So it looks something like this. And in the loop of wire, we'll draw some arrows to represent the direction of the current, because it says a clockwise current of 5 amps exists in the wire. So in part A, determine the magnitude and direction of the magnetic force exerted on each of the 4 sides of the wire. So we'll start with the 2 easy sides, the top and the bottom. For the top, since the current is in the same direction as the magnetic field, the angle between them is 0, so that means the force, which is ILB sine of theta, is also going to be 0. We can just say because they are parallel. Same thing happens in the bottom. Since it's going in the opposite direction of the magnetic field, the force is 0 because the angle between them is 180 degrees, and so whenever the magnetic field is anti-parallel to the current, the force is also 0. Which just leaves the left side and the right side. So the equations for both of these are F is equal to ILB sine of theta. Since both those sides are perpendicular, the sine of theta, which is 90 degrees, is just going to be 1. So the force is just equal to ILB. The current is 5. The length of each side is 2 centimeters, or 0.02 meters. And the magnetic field is 0.3 Tesla. So when you multiply them, you get 0.03 newtons. So the magnitude is the same for both of those parts of the wire. What's different is the direction, because for the left side of the wire, if you put your fingers in the direction of the current, which is upward, and turn your hand so that your fingers can curl toward the right, which is the direction of the magnetic field, you see that your thumb is pointing into the page. But on the right side of the wire, if you put your fingers in the direction of the current, which is downward toward the bottom of the page, and curl them in the direction of the magnetic field, your thumb is then pointing out of the page. So the left side of the wire goes into the page, and the right side of the wire goes out of the page, which means that in part B, based on those 2 answers, the motion of the wire loop is going to rotate, but it's going to rotate around an axis that is kind of through this part right here, with the side on the left going into the page away from you and the side on the right coming out of the page towards you. So to be more specific about the nature of the rotation, you can just say the left side goes in and the right side goes out.